Hello, my name is Joan Martinez, Mechanical Engineering. I will explain the difference between normal effort and their stress shear. Effort is this force per unit area or the strength of the force distributed toward a given section. Normal effort. The normal effort produced by flexion are called flexion stress. The forces related between this and the flexion moment are deduced by the flexion formula. The normal stress, axial or axial stress, is the external stress or resultant of the then perpendicular normal stress toward the cross section of mechanical springs. This type of the stress formed by parallel voltage is the difference associated with the normal voltage offered that is perpendicular to the plane on which the tensile or compression for a plate which is evenly distributed toward is the surface, also called axial stress. Some mechanical characteristics of the material, such as the resistance, ability to resist breaking, the rigidity, and ability to reset deformation, and their ductility, ability to deform before breaking, are usually obtained by laboratory test experimental material resists, testing certain portions of the material, standardized test tests, to obtain this information. It seems that the first to perform tests to know the resistance of wires was Leonardo da Vinci. What probability the first to systematize the testing and publish the result in the form of a law was Rubik hook. Submitting all call it wire springs to the action of different loads and measuring the deformation produced, which allowed him to enunciate the results obtained in the form of law, as tension is force, in his interesting publication in 1678. This is what is now in this modern form as the Hooke law. The best way to understand the mechanical behavior of material is to subject is to do a certain action a force, and measures is the response the deformance that occurs. Cutting or cutting effort. The force applied to the structural element can induce a sealing effect on the part of it with respect to another. In this case, a sharing tangential of the stress is produced of the steel area is figured, and equals to what happens with normal stress. The shear stress is defined as the relationship between the force and the area towards which the slips occurs where the force is parallel to the area. Hooke's law can all be established for cutting in a similar way to the normal stress, so that the shear stress will be a function of the angular deformation and the shear module of the shear material. The elastic modules and are related by the expression MOTT 1999. The shear stress of the shears is the which, when applied, is fixed and tangent to the usually represented with the get letter toe in the located page such as beams and pillars. The reference plane is usually parallel to the cross section. Finish. Thank you for your attention.